Today in this class we discuss about complementary metal oxide technology and its application to implement digital circuits. So first of all, what is a CMOS? CMOS is basically known as complementary metal oxide semiconductor. That means in this CMOS there are two MOSFET are working together. One is NMOS and another is PMOS. So PMOS or NMOS, P channel metal oxide semiconductor, and this is N channel metal oxide semiconductor. So embed both this technology in a one single chip is known as complementary. Why it is named as complementary? Because at a time one MOSFET is on and another MOSFET is off. So look at here in the left side diagram. So in this diagram, if we plot one truth table V input versus V output, then when V input equal to 0, then P MOSFET, here bubble sign is denoted, this is depletion type MOSFET, and here no bubble means this is N MOSFET, that means enhancement MOSFET. And that is when this is equal to 0, then this MOSFET is on. So now this MOSFET is on, therefore the voltage appears here, but this N MOSFET is off, so therefore we get output equal to 1. But when this input equal to 1, that means when V input equal to 1, then N MOSFET is on but P MOSFET is off, so there is no connection between N MOSFET to VDD, so that means the output equal to 0. So this is the first concept of complementary metal oxide semiconductor, also known as CMOS inverter or CMOS NOT gate applications. Okay, so the transfer characteristics is look like that. If we plot here V input versus V output, then just shown here. So this is the transition region, okay, where the logic 1 is goes to 1 to 0. This is known as the transition region. So using these two MOSFET, we can implement our CMOS concept of CMOS topologies. So this is known as CMOS inverter circuit operation. Next is known as CMOS NAND gate. NAND gate means the equation of the NAND gate is y equals to a dot b whole bar. So there is some method to design the NAND gate using CMOS. So first of all, there are two equivalent network. One is NMOS equivalent network and one is PMOS equivalent network. So how to solve it? So first of all, from this equation we can apply De Morgan's theorem. So this is known as PMOS equivalent network. So y equals to a dot b whole bar. That means if we apply De Morgan's here, then it is equal to a bar plus b bar. And the NMOS equivalent network is just uncomplemented from, that means a dot b of this equation. So we all know that any variable in an AND combination, that means the transistor connected in a series, and if two variables or any variables are in an OR operation, then transistor must be connected in a parallel combination. Okay, this is very important. So now here two PMOS, which input is a bar plus b bar, that means this is a bar, a complement, here one PMOS, and this is b complement. So this upper network is known as PMOS equivalent network. Okay, and a dot b, that means this a input, one NMOS and another NMOS are connected in a series, that means they are in AND operation, and just their two drain terminal are short circuit together and one common output is present, which is known as the output terminal. Okay, so from here we get the output, and the equation is y equals to a dot b whole bar. So that is why this is the method of CMOS NAND gate circuitry. Now next one is CMOS NOR gate. How is it possible? This is the NOR gate equation. So first of all, we know that for a P equivalent network we apply De Morgan's. So this is the De Morgan's a or b whole complement, that means a complement dot b complement, and the NMOS equivalent network is just yn equal to a or b. So we know that if two variables are in AND operation, then transistor connected in a series. So that's why these two PMOS are in series. That is depletion type MOSFET. And here for a NMOS network, two variables are in OR combination. That means two transistors with input A and B are connected in a parallel combination, and there are two drain terminal. This drain and this drain terminal are short together to form the one output, to make the one output, which is known as a or b whole bar. Okay, so this is the CMOS NOT gate circuitry. Okay, so this is very important. This is very much important. Okay, now this is the design of CMOS AND gate. How is it possible? AND gate means there is no complement. So first of all, it is very important how AND gate is designed. Before AND gate design in a CMOS, when any logic is designed with uncomplemented form, then the rules is first we created its complemented form and design it. So first here we given that y equal to a dot b, so therefore we design y equal to a dot b whole bar. So what is a PMOS equivalent network? Apply De Morgan's. What is NMOS equivalent network? Uncomplemented form. So these two are in OR combination, that means these two transistors in a parallel combination and these two variable, that is in a series combination. So from this output we get a dot b whole bar. So how to omit this complement? So here we connected one inverter. That means this inverter helps us to omit these one complement, that means y equal to a dot bar. From this output, the output is a dot b whole bar, and here a dot b double bar. That means we get a dot b and operation. Okay, so this is very important. So one thing should be remember, if in a CMOS logic circuit, if we design any logic with a non-complemented, then first we design the complemented form and then omit this complement by using inverter circuit. This is the basic fundamental rules. So now we talk about our CMOS OR gate. So this is y equals to a or b. This is again uncomplemented non-complemented form. So first of all we design with a complemented form. So y equals to a or b whole bar. That means what is the P equivalent network? That means a bar dot b bar. And what is NMOS equivalent network? Just uncomplemented form. So now we design, that means these two are in AND operation. So there is a two MOSFET is in series combination and these two variable are in OR operation. So therefore these two NMOS are in parallel combination. So tied together, these drain and these drain are short circuit together to make the output y equals to a or b whole bar. So how to convert in uncomplemented form? We just connected here one inverter or one NOT gate. So that is produced a or b operation. Okay, so this is very important. Okay, so now we study about lots of things. So this is about another logic, y equals to a dot b plus cd whole bar. So what is NMOS equivalent network? Just uncomplemented form a dot b plus c dot d. What is a PMOS equivalent network? Just do it, apply the De Morgan's theorem. So y equals to ab plus cd whole bar, that means ab bar dot cd bar. So again De Morgan's applying De Morgan's. So therefore this a dot b whole bar equals to a bar plus a bar or b bar dot c bar or d bar. So therefore this is NMOS equivalent network. Therefore a and b are in AND operation. So therefore these a and b are in series. One thing should be remember, in a digital electronics, if any logic are in AND operation, then the transistor always connected in a series, and if they are in OR operation, then transistor connected always in a parallel. So now next our CD is a AND operation again, and what are the logic between them? The logic is OR. So that is, this is the total in a parallel combination. That's why it is look like this. So now what is a PMOS equivalent network? First of all, these two are in OR operation, that means they are two in parallel combination. Then these two are in parallel combination, and then between this is AND operation. So this is the in these upper network and lower network are in series combination. Now this is known as NMOS equivalent network, and this is known as PMOS equivalent network. Okay, now they are tied together. How is it possible? First of all PMOS, and then first of all we draw the PMOS and then NMOS. So now this is okay. First of all this is right hand side and then left hand side. Now look at here, this is our PMOS equivalent network and this is our NMOS equivalent network. Okay, so and generate the output y equals to AB plus CD whole bar. And if we implement just only AB plus CD, then just from here we connected one inverter. Okay, this is one inverter VDD drain supply, and here from here we get AB plus CD, AB or CD. That is this inverter circuit is again complemented this logic and non-complemented from AB or CD. Okay. Okay, now next one is very important. Next one is again another logic and design. Now, okay, now this is our next logic. Y equals to A or B dot AB or C whole complement. So what is NMOS equivalent network? Just out this complement. So this is A or B dot AB or C. So what is the PMOS equivalent network? Applied De Morgan's theorem. So this is A or B whole bar or AB or C whole bar. And again apply De Morgan's. This is A bar dot B bar or C bar dot A bar or B bar. Okay. So now this is NMOS. So first of all, these A and B are in OR operation. So that is these two are in parallel combination. OR means parallel combination. And this AB is an AND operation. Now this is an AND operation with or with C. That means this C and AB both are tied together in a OR combination. That is in a parallel combination. So this is NMOS equivalent. So now what is a PMOS? First of all, PMOS, A bar and B bar are in series because they are in AND operation. So now this is in series. These A bar and B bar are in parallel combination because they are OR operation. This is a parallel combination with AND operation C bar. This is AND operation with the C bar, and then the whole operation with OR operation. Therefore, this side and this side are in parallel combination. Okay. So now they are tied together. So upper part and the lower part. So now how is it possible? So students, please, it is your task to design the whole circuitry. So first of all, I tell you, so first of all, this is a PMOS equivalent and this is NMOS equivalent. So how to design CMOS? So first of all, you draw the PMOS and then NMOS. Then these two drain terminal, that means this out one drain terminal and this out one drain terminal are just connected together and make a CMOS equivalent circuit. Okay, please do it and draw the complete CMOS circuit. Okay, so now this is one interesting part of known as CMOS non-inverting buffer. This is very important, also known as the transmission the logic. So now this is the input A, this is one hex inverter, and here connected one again inverter. So that is the output is equals to Y equals to A complement, and this complement again input to the one inverter, and the output equals to Y equals to A double complement, that is equals to Y equals to A. So this is known as CMOS non-inverting buffer circuit. This is very important. There are two inverters are connected. This is one inverter, this is one inverter.